Welcome to the first lecture of Module 8. In Module 8, we are going to discuss on evaporation, and to start with, that means with the first lecture, we are going to discuss on introduction to evaporator and introduction to evaporation and evaporator types. Now, to start with that evaporation, so what we mean by evaporation? In general, we mean that evaporation is nothing but vaporization of a solvent from a solution to make it concentrated. That is what is in general means mean by that. So, that solvent is volatile or it is evaporated, and the other part is nothing but that is called the solute, which is almost non volatile in nature. Okay. And the product that we are getting after evaporation is nothing but a thick liquor. So, we can say that evaporation is nothing but concentration of a solution through vaporization of the solvent, and what we are left with is that a thick liquor. So, vapor is gone. So, residue is called thick liquor, and that solute is non volatile. That means, its volatility is very small. Solute need not be a solid substance that is dissolved in the liquid. It can be even a gelatinous substance or maybe a liquid substance which is having very low volatility. That time also we can think of that this is a method of evaporation. For example, we know that drying of gelatin, aqueous gelatin is an example of that evaporation, where the gelatin is drying of gelatin or glycerin, this kind of substances which are highly viscous and very low volatility is there for them. They are not solid substances, they are maybe viscous, highly viscous and semi solid or gelous gel type of substance. Okay. Now, typical examples of evaporations are that we know that in sugar industry, concentrating cane sugar juice, concentrating in fertilizer industry, similarly in food industry, that is many other type of fruit juices is also important. Similarly, in fertilizer industry, it is concentration of say ammonium sulphate. Then in alumina plant, it is concentrate or recycled sodium hydroxide, concentrating sodium hydroxide solution. Okay. So, these are the typical examples of this. Now, the question comes that what is the difference between drying and evaporation. So, drying versus evaporation. And we know that in case of drying also that the solvent is evaporated, that means and evaporation also the solvent is vaporized. So, then what is the basic difference? In case of the basic difference here is that objective of this operation. In case of drying, the material, the solvent is totally vaporized to have a solid residue. So, we can have a solid residue here, and in case of evaporation we will have a concentrated solution which is called thick liquor. Okay. So, this is the major difference between the drying and evaporation. This is also you can call as the viscous solution is obtained. So, this is due to concentrating. Okay. Now, next part is that another question comes is that typical example of drying is that drying of milk to produce milk powder. So, for example, drying of milk to produce milk powder. Okay. So, here we are getting a solid substance, that is in case of evaporation we are not getting the, we are not interested for the solid substance, we are interested for getting it concentrated. Now, second part is like what is the difference between now distillation versus evaporation. And we know that distillation is also is that vaporization of the volatile liquid part which is getting vaporized. So, in case of distillation we know that it is basically the two liquids or two or more liquids having some differences in their relative volatility, they are being vaporized, and then in the vapor part, once they are vaporized, in the vapor part they are getting again separated. Okay. So, they are getting not only vaporized and then to the vapor phase are getting separated by distillation. But in case of evaporation there is no attempt in this case. So, in case of evaporation what is happening is mostly a pure component is, that is the solvent which is getting vaporized. So, in case of here in case of evaporation it is mostly a pure component which is getting evaporated, and that vapor no attempt is being taken to get that vapor separated, because if even there is a mixture of some components, because if the solvent is a mixture of another liquid component which will also have some kind of vapor percentage in the vapor. So, there is no attempt is being taken to separate those components. Okay. That is why that is the difference between distillation and evaporation. Okay. So, we can say that next part. So, distillation is, as we know that it is mostly, as I told you, between two liquids, and it is liquids and solute. Solute can be a liquid or it can be a solid portion, but it is a non-volatile, almost zero volatility. As I was telling, a typical example of dilute solution of glycerine is an example, but dilute solution of glycerine, when if we think of distillation, we can never do, because the vapor of glycerine in the vapor phase, okay, when with water vapor is almost nil, almost negligible. So, there is no separation is possible by that way. So, this is the difference between the distillation and evaporation. And then comes that crystallization. Yeah, during the crystallization we require the evaporation to take place, because through evaporation what we are doing is we are concentrating the solution, and that means we are taking out the solvent as much as possible. We are concentrating the solution and we are trying to make it supersaturated. Supersaturated by evaporation of solvent from solution, and then crystals grow in supersaturated solution. So, that means we can say that crystallization, for crystallization evaporation is a first hand information, first hand requirement. So, we can understand from there that evaporation is one important unit operation for chemical engineering, particularly for chemical engineers and for any chemical process industries, and we should know that different type of evaporators and what are the basic concepts and how to calculate or do design for the evaporators. Now, so before we discuss further about the different types of evaporator, there are some important issues like that what are the properties and how these properties would have an impact on the design of the evaporators. So, when we say that following properties of evaporating liquids. So, the properties of the evaporating liquid I am going to list down, they have impact on the design of the evaporators. The properties are the concentration of the liquid or solution, then foaming property, then temperature sensitivity, then scale formation. So, these are the 4 important properties we should be clearly we should understand clearly while going for any kind of evaporator design. Now, if we just see this concentration part, so usually thin liquor sulphate, that means very dilute, having property equivalent to water. Okay. This is one thing, and but what happens is that with increased concentration changes viscosity, boiling point. We know that is called elevation of boiling point, and then there are many other issues like specific heat, etc. So, we have to be pretty careful while calculating this, that what happens to the property changes and how to take care of these things. So, this is that the concentration, effect of concentration on the evaporator design. Then so, we have to see that the salting out effect, or I should say that scale formation we will discuss later. So, salting out effect at higher concentration, that means at higher concentration whether it is getting crystallized, whether any crystal formation is there or not. So, all these things is very important. So, if any crystal formation, because this crystal formation what it does, it blocks the tubes. So, there will be a problem in the evaporation phenomena. So, these are the typical things that has to be seen, and also we have to see that to what extent that viscosity is increased. So, that whether there is a flow ability or not, and we know that increased viscosity will create what that change in heat transfer behavior, heat transfer coefficient. So, these things, all these things are related to concentration of the evaporating liquid. So, we have to be pretty careful about that how is the concentration and how is the properties are being changed, and and these are to be taken into considerations. Second part is the foaming, and we know that foaming is one important issue, that when the boiling phenomena comes, then there will be foam formation, and that foam means that that fine droplets of particles will will be getting entrained along with the vapor, and so there will be a lot of liquid losses, and this particular happens with organic substances. Okay. So, we should see that there is a sufficient length of the tube is there to take care of the foam, and so sufficient length of tubes to take care of foams, or also we have to see that any plate, what is that impingement plate, to detach the entrant droplets. So, these are important issues related to the evaporator. And then temperature sensitivity. As we know that temperature sensitivity is very important, as because it is that the heating is there, evaporation means it is heating and the liquid gets boiled up. So, that if the liquid material is highly temperature sensitive, then we should be pretty careful about that, because at high temperature, if we put the exposure at high temperature is very important. If we give long exposure at higher temperature, then there can be a damage to the materials. Okay. So, that is one very important thing that should be particularly seen, particularly for say fine chemicals, pharmaceuticals, and then we can have say any food products, enzymes. So, these are highly temperature sensitive. So, we have to see that that it is not given a long exposure at higher temperature. And then say next part is the scale formation, as I was telling. This is nothing but a deposition of the scales on solid heating surface by some solution. Okay. And so, it is a deposition of scales on the solid surface. And this scale deposition may be due to the dissolved solutes. These solutes are just getting deposited. Sometimes it is due to salting out effect also. That means, the salts come out from the solution, it gets precipitated or deposited. This is called salting out effect. So, it may be because of that reason also that solutes get deposited on the surface, and as we know, the thermal conductivity of the solutes are very low, and so therefore, the heat transfer coefficient will drastically reduce. Coefficient will drastically reduce. Okay. So, therefore, this has to be taken into consideration while going for any such heat exchanger design. Now, come to the next part, which is called the material of construction. What kind of materials of construction we should use in case of evaporation design? It is usually or mostly made of some kind of steel, that is just because we know that it is operating at some high temperature and the boiling liquid is there, and the other side there is the steam. Usually the condensing steam is used for heating purpose. It can be any other heating medium, but usually the condensing steam is used, and the liquid is which is being evaporated is basically at a higher temperature at its boiling point. So, at high temperature the corrosion chances are much more, and therefore, some kind of steels are generally used, but for highly corrosive fluids, special materials like copper, nickel, some stainless steel and aluminum, okay, impervious graphite, etc. are used. So, we have to see that because these are used, so these are pretty costly. So, we should see that we should look into the fact that heat transfer coefficient is maintained high. Okay. This is because higher heat transfer coefficient means we need to have less surface area, that means less consumption of these materials. So, that is one important criteria that we should have high heat transfer coefficient to reduce area or size. So, actually this is the intention of anybody would be that we should see that high heat transfer coefficient or to reduce the situation, to reduce that area of heat transfer, that will automatically, this will always reduce the cost, capital cost investment, but sometimes it may not be possible due to some external the constraints. But here when we are having some highly corrosive materials that is to be used, and that time, and if we are using very highly costly materials like copper, nickel, or say aluminum, or such kind of materials are used as material construction, in that case it is advisable that the special attention should be given to these kind of things, so that the size requirement is drastically reduced. Okay. So, in that case that capital investments will be reduced to a considerable extent. And then many other characteristics also that we should know in case of evaporator design. There is a specific heat, heat of concentration, freezing point, then of liquid, definitely gas liberation, toxicity level, then explosion hazard, radioactivity, okay, and then radioactivity, etc. So, these are the certain information that we should have regarding the solution which we are going to concentrate, particularly for a evaporator design. So, thus we should be pretty careful about that liquid characteristics while going for the evaporator designs, as we have discussed in many ways. Now, if we just to see the type of evaporators, we will concentrate on the different types of evaporators, that we will see that there are different types of evaporators has come, and mostly the evaporators are of is kind of selective heat exchanger kind of things. So, that so tubular surfaces are there, tubular surfaces are the heating surfaces, okay, and that can happen in two ways. One is called a natural circulation evaporator, and another is called forced circulation evaporator. In the natural circulation evaporator means that natural circulation means that liquid which is getting evaporated, it is flowing with the help of a density difference. It is a gradient of density. Because of the changes in temperature, there is a density gradient, and because of the density gradient, that fluid moves. That is called natural circulation. Another case is that forced circulation, where that the density difference, though it works, but it is needed to have the liquid to be flowing in a better speed, higher speed. In that situation, there is a necessity of putting a pump which will give a flow to the additional energy to the fluid for the flow. Okay. So, that is called forced circulation. In the natural circulation, there are two types. One is called short tube vertical, which is called calendar type, another is called long tube vertical. This is called short tube vertical, another is called long tube vertical. And forced circulation, we have normally the long tube recirculation type, which is similar to this long tube vertical only. And this, as I told you, that this forced circulation is needed particularly for highly viscous liquids, for heat transfer coefficient, that is to increase the heat transfer coefficient, because at low velocity their heat transfer coefficient will be low, and for solution containing suspended solids. So, what happens that suspended solids, they may clog the pores, tubes, so not pores, they may clog the tubes, they may get separated from the main flow. So, if you have a high velocity, then the suspended solids won't be separated from the flow regime. So, they won't clog these, they will be remaining suspended in the fluid at higher velocity conditions because of the drags. And for heat sensitive materials, they cannot be allowed to stay in the evaporator for a longer time. So, we need to have a higher velocity, so that the residence time in the evaporator is less. So, that is why these forced circulation kind of thing. And then there are various other types of evaporators are falling film, climbing or rising film, and agitated film and plate type. So, we will be quickly discussing the different aspects of the evaporators. Just as I told you that if we start with that first one is that natural circulation innovation, and it is happening due to as I told you that it is basically due to gravity density difference, and here this is a typical example of a natural circulation evaporation, which is that short tube vertical, and it is also called calandria. You can see that this is this portion, this is the cell. So you have a tube bundle that is placed in the cell, and it is here it is flanged, and then this cell is called, this small cell is called the calandria, and the tubes is placed over here. So, in this case what we can see is that the feed is coming from here, and we can see that that it comes like this, feed comes like this, and then it goes like this. So, this is the circulation that it takes place, okay. And this portion, this is the calandria, you can see here, and this is the thick liquor, it is going out like this, and this is the feed coming. So, it is a smaller tubes, and we have that this is the vapor region, the vapor is coming like this, and okay. So, then we have that the thick liquor will be coming like this from this through the hollow, this is the liquid will flow like this, and then it will go to the tubes, and then finally the thick liquor will be drained out from this, okay. So, this is what is being done in the case of a short or calandria type of evaporator. And through the tube, when the liquid goes up, so it goes up due to the density difference. So, the high temperature liquid at higher temperature will have lower density and like that, and there will be, and while it is going there will be vaporization. So, there will be the effective density will be reduced, and that it will come it will go upward. So, this is called that gradient, due to the gradient it will go upward, and so this portion is called this portion where it is called the downtake or the downcomer. This portion is called downtake or downcomer. Okay. Now, what happens is that typically that in this case, in case of calandria type evaporators, their diameter is typically 1 to few millimeter for calandria or cell dia, we can say, and tube dia is usually 2 to 3 inch, okay, and tube length is usually 1.2 to 2 meter, okay, and downcomer area is nearly 50 to 100%, okay, of tube flow area, okay, and that as we see that this is, there will be some entrainment separator here. This entrainment separator is here just to see that there will be no vapor, no liquid bubbles are entrained in this region with the vapor, okay. And so, if we see that the uses are typically to concentrate variety of solutions, typically sugar solution, okay. That calandria, it is not suitable, sorry, this is not suitable for solutions in which precipitate or salting out of, as I told earlier, salting out of solid may occur. Okay. And then what will happen? Why it is not suitable? Then what will happen? Because it is a natural circulation, that force of the liquid is not that much high. So, what will happen is that it will not allow, it will not take the deposited solid materials along with itself. So, they will be staying and they will be clogging the pores of the tubes. Okay. So, solid particles cannot be in suspension. Solid particles cannot be in suspension, and so clogging will take place. Okay. So, this problem to some extent can be overcome by putting some propeller. Okay. So, we will show you that this is the propeller rearrangement. So, there is a propeller here, that putting this thing propeller. So, the whole thing is called propeller. This propeller calandria, using propeller calandria, what we can do is, here we can just put some kind of circulation here. So, we are putting some kind of circulation, and using the circulation we are increasing the speed of the liquid passing through the tube. Okay. Speed of the liquid passing through the tube, that we are able to, this is the tube, through tubes they are passing. So, speed of this is passing through the tube. So, it is this is the downcomer section. So, we can, by putting the propeller kind of things, we can make it to go through the tubes, and then that salting out effect can be to some extent avoided. Okay. So, this is called propeller calandria, and we can see that it is also similar to, the short tube vertical. These are all called short tube vertical evaporator, and so short tube vertical evaporators are called short tube vertical. This is called short tube vertical. The short tube vertical evaporators are, these are also called standard, okay, evaporators. They are standard evaporators, and their advantages are, they are of low cost, then easy cleaning, then low headroom requirement, okay. But disadvantages are, it has got some disadvantages, undesirable for viscous liquid, then okay, because the reason is offer low heat transfer coefficient, because the flow is very small, because of natural circulation the viscous liquid will not be allowed, okay, and also require larger floor space. So, what we can understand that the tube bundle should be of bigger size, because the tubes are of smaller size. In case of calandria, the tube's length is smaller, so tube bundle should be bigger in size, and therefore, the flow area requirement will be relatively high. There is another kind of short tube vertical evaporator is the basket type vertical evaporator, and what we can see here, that in this case it is just arrangement is a little bit changed. What we can see here is that the steam is inside this portion and feed is in this region. In this is the region where feed is. So, feed is in the annulus, feed in the annulus, and steam is inside this region. Okay. And so, this part is like a basket, okay, which can be just taken out for cleaning. So, this gives a very easy cleaning operation. And so, here what is happening here that the hot liquid flows down the annulus. So, the hot liquid flows down the annulus and then goes through the tube to upwards, okay, through the annulus, and steam enters the chest. The steam enters in this region in the chest here, and that through this pipe it is entering here, it is the steam is entering here. Okay. So, this is what is happening here, and then finally, the thick liquor is being collected from this thick liquor is coming out. Okay. Now, here it is mainly used because it can better handle the scale formation. Okay. Because of easy cleaning possibilities. Okay. So, this is the advantage of this advantage of basket type, is that basically nothing but the easy cleaning and maintenance. Okay. So, this is that short tube vertical evaporator, that is again that basket type evaporator which is being used for natural circulation purpose, and we have seen that there are three types of calandria. It is a normal simple calandria type, another one is with a propeller arrangement, another one is with a basket arrangement. So, in case of propeller arrangement, the propeller is just to increase the speed of circulation, that takes care of any kind of scales being deposited over there. So, allowed them to be suspended, and another case is here is that basket type, where that just flow direction is reversed, where that reverse in the sense ki it goes to the steam is in the central portion, and the liquid to be evaporated in the annulus portion, and it is because that the tube bundle remains like a basket, and it can be taken out easily and can be cleaned. Okay. Now, the another type is, as we have seen, is the nothing but the a long tube vertical evaporator. This is also goes by the natural goes by this natural circulation mode. And what happens here again, that we can see here that the feed is coming here, and then feed goes through this tube, upward. Now, what is being targeted in case of this is that here these are long vertical bundle, tube bundle, fitted with a cell, okay, and feed enters at the bottom and flows through the tube once, okay. And it is being seen that the important things of this is that as we have seen that feed goes like this, and there is a separator plate where the entrainment is to be stopped, and then the vapor goes to this and this is the entrainment separator, and then vapor comes out like this, and then entrained liquid, as we see that entrained liquid comes out like this, okay, and there is the thick liquor that is coming out, and this is called steam trap, and there is a vent. Vent is for any kind of condensable, a non-condensable gas, if it is there, that would be, that is allowed to come, and the steam chest, the steam is going for heating, and the resistance in the okay. Now, so important point over is this resistance of condensing steam on cell side, that is always there, is small, that is always true, but what happens is that in case of long tube, initially heat transfer coefficient is less and then increases due to boiling. Okay. Once the boiling starts, turbulence starts, so the heat transfer coefficient increases, and then so liquid at lower point, in this case, that the liquid at lower point will boiling at higher temperature, liquid at higher point will boil at lower temperature. The reason is here due to the hydrostatic head and frictional drop, all these things are there. So, the pressure in this liquid in this portion is high, the pressure in this portion is less. So, the boiling point is more, the boiling point is less. Okay. And then usual things are that LTV, long tube vertical evaporator, they have tubes of 3 to 10 meter length and 1 to 2 inch dia. Okay. Tube bundle dia is less than STV, short tube vertical cases, and sometimes baffles are also used for baffles in cell side to have more uniform flow of steam. Okay. And now, the use for these cases, we can say that it is a paper and pulp industries to concentrate black liquor, okay, then concentrating NaOH solution, then foaming solution. So, because it is a long tube, the foaming solution use will be easy, and corrosive solutions also used. Okay. Now, similar kind of one is that a long tube vertical recirculation type. It is a similar kind of things, that here the flow is not once, flow is not once through. So, that means, in case of simple long tube vertical efficiency, the flow is just going through once, but in this case flow is not once through, that means, it is circulated. So, flow is circulated. So, circulation is there, okay. And the reason is flow is circulated, the reason is to get high heat transfer coefficient, high transfer coefficient, and then low cost. These are advantages: low liquid hold up, less, these are all advantages, less floor space requirement. Okay. But disadvantages are high headroom requirement, and unsuitable for viscous and scale forming materials. Okay. So, this is what is that it is a long tube vertical, you can see here with a recirculation. So, things are getting recirculated here. So, long tube vertical recirculation heat exchanger. Now, there is another kind of heat exchanger is that there is the forced circulation. So, here in this case the forced circulation is when that natural circulation does not succeed. Now, when the natural circulation does not succeed, already I told succeed. What are the cases? That means the cases of viscous liquid, then suspended solids, heat sensitive materials, so under those situations natural circulation does not succeed. So, then it is better to use the forced circulation, and using forced circulation what is being done is that that velocity is increased. So, for viscous liquid that it will be there will be high heat transfer coefficient can be obtained, and for suspended solids solids can be kept suspended because of the high velocity, and for heat sensitive material the reason is that once velocity is high that it will go through the evaporator once. For a smaller time it will pass through the evaporator, and so exposure time will be less for the heat sensitive materials. Okay. So, there is this for forced circulation unit, it is a similar type of whatever is being discussed for natural circulation cases, but only thing is that here what is only some pump is needed just to give that energy to this thing, give some energy to the fluid so that it passes through. Now, there are two more, but only problem with this forced circulation is that, so advantage, these are the advantages of the forced circulation unit, but disadvantage of this forced circulation unit is that it is high capital cost because of the pumps, high capital cost, okay, and high headroom requirement. This high headroom requirement cases is that cases when the tube is not allowed, the fluid is not allowed to boil in the tube, and then what is happening that it is taken to the vapor flashing zone, where in the headroom that there that reduced pressure is, the area is reduced, the volume is increased. So, and the temperature will be less, and that the liquid can flash over there, and then therefore, that for flashing part the vapor is to accommodate the vapor, that high headroom requirement is there, that is needed. And then there are some other types of one thing is that one is falling film, evaporator, and we know that in case of falling film evaporator we have mostly that what is happening that liquid is allowed to fall, okay, like a film, right, and this the falling film evaporator is most important factor in this case is that most important factor is liquid distribution. So, from the name itself we can say that liquid is falling down in the form of film, okay, and this will be the, so if we have that this is the tube, so liquid will falling as a film here. So, falling film, this is the film, and this portion will be the vapor, okay. So, vapor from the in the core it will go upward and the liquid will fall down, and so vapor will be generated and this will come from the liquid, so vapor will be generated and it will come to the upward direction. So, what is important here is that is the liquid distribution and to maintain the film, and the advantage is, and for that to maintain a film, Reynolds number defined as 4 gamma by mu, where gamma is liquid rate per circumference of a tube. So, this Reynolds number is this is greater than maintained greater than 2000. Okay. So, this is what is being done, and the advantages of this is the falling film is that heat transfer rate is high and good for heat sensitive material, and then minimum viscosity upper level limit of viscosity is mu is equal to 100 to 500 Cp. So, it is not good for high viscous, because in that case that film will be very thick. Then another one is the climbing film evaporator. In case of climbing film evaporator, it is like that there will be the boiling liquid will flow upflow through the tube. So, here in this case climbing film, the vapor will go. So, there will be liquid, initially it will be liquid, then bubble, then slug or bubble, okay. And then there will be, this is the vapor zone, this is the vapor zone, and this is the film, liquid film. So, what will happen, that the vapor will take along the liquid. So, liquid will climb upward, that is why it is called climbing film. And here also, this is also similar kind of utility advantages it can get, similar advantages, and that can be obtained using climbing film evaporator. Okay. And then there are some other kind of evaporators. This is called agitated thin film evaporator. This is also used for highly viscous. This is used for highly viscous liquid, and its viscosity is range is we can say it's a very high, maybe 10,000 to 20,000 Cp viscosity. So, what is happening there here, because of this rotation, the rotor blade is there, because of the rotation over here, this here you can have that a liquid film as is shown, liquid film will be generated, and there will be just thick liquor will come down. This is what is being used. So, for highly viscous liquid, and there will be some agitation. So, we will maintain a film, and the film thickness is maintained here. In this case, heat transfer coefficient or heat transfer coefficient is increased, and then we can say that fouling of surface is reduced, and okay, and keep film thickness small, okay, and so blade clearance nearly equal to 1.5 millimeter. So, based on that, the film thickness will be maintained over there. So, these are the advantages that we get, and this is used for. So, agitated thin film is used for evaporator is this is the advantages of the agitated film beam evaporator, and is used for very highly viscous material. Okay. And then if you see here that it goes to that, this is the region, this is called the vapor region, and here it is of high size, so that vapor can be that reduced here that pressure is reduced, and that liquid entrant liquid can come down. And then the another one is the plate type heat exchanger. Here it is similar to is the plate type similar to plate type heat exchanger, it is a plate type evaporator, and here in this case also it is, we can say that can be rising film / falling film mode or a combined mode. That is what it can be used for high viscous liquid of say 20,000 Cp of this range viscosity. Okay, this is used, and this is also good for heat sensitive and foaming solutions. So, in the plate type heat exchanger, in one side there will be a steam, and in another plate one side there will be steam, and another one side will be heated, and the other side there will be the liquid that will be there. Okay. This is the plate type heat exchanger that is being used. So, typical example plate type evaporator, here example is concentration of malt extract, gelatin, okay, glue, emulsion, etc. Okay. So, these are being done using the plate type evaporator. So, plate type evaporator is similar to plate type heat exchanger. Now, these are the typical examples of various types of evaporators and the products being handled, that already we have discussed. Okay. And we can see there that plate type and the differences are there in these cases. If you see that for forced circulation, that salting and scale forming sodium ions and sodium sulphate solutions, whether on agitated film, that is the high viscous material, gelatin or glue, similar it is for plate type heat exchanger. Okay. And rising film and falling film, these are for low to medium viscosity materials, these are used, and fruit juices and all. So, this is used for this kind of evaporators. So, detailed analysis, detailed study can be made, but I should stop here regarding this type of evaporator design, type of evaporator descriptions. So, this is all for this lecture. In the next lecture, we will discuss on the different principles involved and the performances of the various evaporators. Okay, thank you very much.